In this video, I'll talk about Coulomb's law. The Coulomb's law tells you the force of attraction or force of repulsion between the two electric charges. So let's say you have two charges, the one positive charge here and the one negative charge here. When you have the two charges separated by a distance r, then there is a force acting between them. The magnitude of the force acting between them is given by this equation here. This is the force, K is a constant, and we'll talk about that constant later. And Q1 and Q2 are the magnitude of the charges. And R square, or R, is the distance between the two charges. What does this equation tell you? This force is directly proportional to the magnitude of the charge Q1 and Q2. More the charge is, the more the force of attraction or repulsion will be between the two charges. The smaller the distance between the two charges is, greater is the force. So the force is directly proportional to, force is directly proportional to the, let me write down here. This force is directly proportional to Q1 and Q2. And the force is inversely proportional to R square. And as I mentioned here, Q1 and Q2 are the magnitude of the charges. And now let me talk about this constant here, K. This constant is a constant which depends on the medium, but for most of our lectures, this constant will be for the air medium only. For the air, or for the vacuum, this constant value is 9 times 10 to the 9 Newton meter square per Coulomb square. And this constant is only for the air or the vacuum. If you put it into another medium, then it will change. All right. And now let's talk about the direction of the force. Again, remember, this equation only tells you the magnitude of the force. It doesn't give you the direction. Now, let's say you have one positive and one negative charge. If you have the two charges, the negative charge applies a force onto the charge Q1 and it tries to pull it towards the charge Q2. So this negative charge tries to pull the positive charge, and the positive charge tries to pull the negative charge. So this force, what does this force mean? F12. F12, that means the force acting onto the charge 2 due to the charge 1 is given here. And F12, what is the F21 means? This F21 means the force acting onto the charge Q1 due to this charge Q2. Okay, and remember, this force and this force are always equal in magnitude but opposite in direction. So these two forces are always equal and opposite. So that's given right here. And again, also by the Newton's third law of motion, or Newton's third law, these forces has to be equal and opposite. To every action there is equal and opposite reaction. So it doesn't matter how big this charge is or how small this charge is, the force acting onto these two charges are always equal and opposite. So this charge exerts a force onto this charge, and this charge exerts a force onto the negative charge, and these two forces has to be equal and opposite. And now if you have the two positive charges, so the positive charge tries to repel each other. So you see now the direction. If the two charges are positive, or the like charges that try to repel each other, the force is away from them. So what is again F12 means? The force acting onto the charge 2 due to the charge 1. And this F21 again means the force acting onto the charge 1 due to the charge 2. And again, this is a repulsive force. So so this force and this force are again equal in magnitude and opposite in direction. And the unit of force is Newton, which is given right here. So that's it for the Coulomb's law. In next video, I'll talk about the superposition.